let's see, a few months ago,
It's on.
Dewey gave me a book by David Springett, Woodturning Wizardry,
You're the driver.
and in it it had this object, which is a spike star inside a cube, and it's sitting on a stand. Robert, if you want to focus right down here, I'll do all my work down in here. So we have a spike star and a cube.
And zoom in on it a little bit.
Yeah. I would zoom in as much as you can right here, and I'll try to have all my work.
Button on the side. Here's the top.
Okay.
Okay, now,
A little bit out. Right there.
Bryce, we're recording, right?
Yes,
Okay, just want to make sure. Thank
the
you.
red light's flashing.
Okay, thank you.
Okay, we ready?
Ready.
So Dewey gave me a book by David Springett, Woodturning Wizardry, and in it this object was in there. It's a spike star inside a cube. That got me thinking about some stuff that I'd seen in other books, where there's a cube inside of a cube, and you can see a lot of this online. And I got to thinking that maybe now is the time to start working on that. But in all the work that I did looking at stuff online, I never did find a straightforward description of how to design the cube in a cube. So I sat down and I did it myself. That led to all of the stuff that's on this table.
Little louder, Jim.
Okay. So I started with the cube. Jim Bob gave me a bunch of 2x2s, and I cut that into 1 3/4 by 1 3/4 cubes and just chopped that up. My table saw is not very good, so I took a disc sander on my lathe with a platform that's right angles to the lathe, and then a fence at right angles to that, and I used that to convert all of these into pretty accurate cubes. Okay, accurate in this case, it does not mean perfect. It means it will fit inside this truck that I made. That's good enough. That's all I ask, is that it fits inside this truck. I'll talk about this later. If I take this cube and bore out each face and then undercut, I'll come up with a structure like this. Let me, can you focus, or not focus, but zoom in? I think it's the button towards the back. Okay. So, when you perform that undercut, there we are. You form this circle, and where these two circles meet, you have this nice crisp line, and then where I'm getting it backwards. There we are. Where 3 of these cuts meet, you get a triangular pyramid, and that forms the inside of this. Okay. And that's the structure that I want to start with. This is the outer cube. Okay. So I'm going to bore and then undercut, and it gives me this light, airy, open structure that you can see a lot of stuff inside. First thing that I realize is if I stop that, grab this. The first thing that I realize, if I stop the cut at a particular depth, do that on all 6 faces, I can have this cube suspended inside the inner cube. I can continue that same concept where I stop my cut. If I stop my cut this deep, I make the inner cube. If I make another set of cuts and stop here, I make the intermediate cube, and then I have a cube inside a cube inside a cube. I put one of these in a raffle. Whoever won that You need to do some sanding on it because that was a demonstration version. I just made it quick and I didn't go back and clean it up. So there's fuzzies on the inside. But if you clean it up and shellac it, it'll look a lot better than it does now. Okay?
Does it matter what wood?
Yes, very important what wood. It has to be a hardwood, needs to be close grained, real tight grain spacing, and no defects. And you'll see pretty clearly on this one why you can't have defects. Let me get- If I stop the depth of my cut here, I'll form that little cube in the middle. And if I leave a 1/2 inch diameter cylinder, then I can turn that to a spike, and that's how you form a spike star inside a cube. This is why you need really good close grain, defect-free wood, because all you have to do is look at one of those spikes with a crack and it'll break. I know that.
So, what are you using to drill with that's leaving the cylinder in the middle?
A screwdriver.
Really?
Sharpen, maybe?
Oh, sharpened, oh yeah. Okay, all of these use the straight-in cut, and all I had to do was vary the depth of the cut, and you make that undercut. Well, this opens up tons of possibilities, because here, I start with, just make a 1/16 inch deep cut all the way across this window, then make an 1/8 inch deep cut to define my wall thickness. Here, whoops, wrong one, here. Then I make a 45-degree cut here, here, and here, just deep enough so that they meet on this diagonal line. And if I do that on all faces, I make the original fidget spinner. These objects are hundreds of years old. This is not anything new. These are hundreds of years old because I've got a book by Hope Zapfel that's published in the 1800s, and he references some people that published the early 1800s, and these kind of objects are in there. So can you imagine somebody, a kid my age, sitting in the back of the room listening to some guy talk and think, this guy's boring me to death. I can't stand it. And he's sitting here flipping this thing, the original fidget spinner. So if you get bored today, let me know. I'll throw one of these at you. I'll toss one of these to you, and you can entertain yourself. But this fascinated me when I finally realized that this simple idea can be turned into a sphere using the same techniques you would normally use as a wood turner. Take that sphere and perforate it, and you can perforate it in any manner you want to form something that's a little lighter, a little airier. Or instead of drilling holes or cutting holes, you can cut a flat. Rotate it, cut a flat, and make an icosahedron, dodecahedron, octahedron, any of the platonic solids you can make. If you take,
We need definitions.
cut this free, mount it between centers.
Do you have cliff notes on this?
Pardon me?
Do you have cliff notes?
I have technical drawings. Oh, I apologize. I was going to bring a handout, but I didn't finish the word parts. I got the drawings, the technical drawings, but I don't have the words that go with them. So I have
Make
the
a QR
drawings.
code, and just give it for the newsletter, and people will be able to download it.
Okay, I will try to get
Or
that
you can
done.
email it to me and I'll get it to the proper person.
That'd be the way to go for me. Okay, so if I'll mount this between centers and turn this thing, then I can split it in half. It's kind of hard, yeah. If you make one of these, make the heart smaller because
Press.
these are infuriating
Press.
to wrangle
Sound.
inside there. But it's 2 hearts. It's a lover's sanctuary. I'll quit. I can start with this object and put post on the flats. Grab those posts by those in a chuck. Turn this guy, and on all of these, you turn through one hole and up to the other. Cut this in half.
The sound's going on that one.
And make a lidded box inside a cube.
Are you cutting it with a skew?
No. I'll show you the tools in a minute.
Okay.
The screwdriver and a spade bit that's been modified. Okay, now, so basically anything I can turn on a lathe, I can turn within this cube by turning through the one hole and looking through the other, gluing post on and that. If I go back to this original concept, if I run tape around here, tape on the bottom and fill that with epoxy, I can make all these objects in epoxy. If I fill it halfway full of epoxy and stick a mermaid in there, fill it the rest of the way, I can turn a sphere with a mermaid inside. Put an LED bulb in here, battery and switch down here, and you have a mermaid swimming around. Put a knight or Gandalf or a football or whatever you want inside there, and you can turn any of these objects with epoxy. You can also embed a star in the epoxy, just make the star small, and yes, the star will come out, but you just stick it back in the epoxy, and you can make wood inside of epoxy inside of. Those are the possibilities. That's all I got to say about that. Okay.
Jim, do you want to start this room?
Oh, if you would please, yes. You can unband those and look at them separately or keep them together, what turns you on. But those, that's what it looks like when it comes off the lathe when I get in a demo mode, where I just go fast and get it done. Okay. Next thing, the tools. These are all basically miniaturized wood turning tools, scrapers. So I start with screwdrivers, and I take and I grind the top flat, and then I grind a spear point scraper on the tip of this.
Again, say what?
I take another.
That's what you said.
I take another screwdriver that's hexagonal, six-sided. I grind down to the widest part and put a square nose on there, and then I sharpen each edge so that I can cut as a plunge cut, or I can sweep it back and forth, make my cuts. And this turns out to be a workhorse. It also turns out to be, as I'm at the very edge of what's useful. This needs to be bigger. The shank needs to be bigger, because it just starts to vibrate if I go any deeper. See? So screwdrivers are a good source of cheap material for making these tools. When I read Springett's book, I grabbed a piece of angle iron, took it outside and cut it up, threw sparks all over the place, and made this tool, and it worked great for making a couple of cube in a cube models. And then I had one catch, and you can see what it did. It wrapped this around the tool post, around the tool rest. I got 1/4-inch steel and made a tool, and it worked beautifully. But I realized it's severe overkill to have a 1/4-inch thick piece of steel. I got to think, where can I get cheap steel that's hard, stiff? And the answer came, I did a project where I needed a whole bunch of spade bits that I was going to regrind. So I went to Retool and grabbed a handful of them, virtually nothing. Paint them, draw out what tool you want, and then I use an angle grinder with a cutoff wheel to remove most of the material, and then touch it up and clean it up on a bench grinder. So between screwdrivers and spade bits, a little bit of white paint, an angle grinder, a bench grinder, and then after I grind these, I never put them on a grinder again. After I get these to shape, I never put them on the grinder again because it removes too much material. I use a diamond stone and they sharpen up pretty quickly. Any questions about this part of it? Standard wood turning tools used in, for the most part, standard ways. Okay. The magic occurs, you can imagine, I cut 5 of these surfaces, I mount this on the lathe, and now I want to cut this last surface. Somewhere along the way, when I cut through, that inner cube is going to break loose. So the outer cube is rotating at speed this way. The inner cube is tumbling around in here.
Thank you.
And I've got a tool stuck in there, and that's a guaranteed catch. I've got to find some way to make that last cut. Some people use a pocket knife or a chisel. You know, they just cut until they get scared, then they use a chisel. Other people turn plugs that press fit in here and holds this. But it takes me longer to make the press fit plugs than it does to make this whole object. Okay, so this is what I came up with. It's a 2x6 that's been threaded to fit the lathe. I did this because the only faceplate that I have, I don't want to dedicate to this project. I want to leave it free to do other things. So I drill and tap a 2x6 to fit on here, put a piece of harder wood to mate against the chuck. Then I turn that 2x6 true. Then I turn the face flat and then hold a sanding block against it, and that flattens that out. I take one of my blanks with the end grain pointing out, wrap one layer of masking tape just to increase the size a little. Put that in here, bring the tailstock up, and center this. I use my fingers to dial it in. Make sure that those corners touch my finger at all the same place so that this block is centered. Then I take a piece of 2x4 and cut these 3/4 inch by 2.5 inch long by about 1 3/4 thick blocks. We might want to go to this camera if that's possible. I take one piece of wood and hold it up against my block. So I take this piece of wood and hold it against my block. I put a spacer in here, and that spacer normally sits down flush. I put this block against the spacer and against here, and I continue all the way around. Rubber band this together, and then put clamps with gentle clamping pressure on here. Push this down, then I come back and I mark the center of my block, transfer that mark over and down, and then drill and tap for 1'8" here. So I take these blocks apart, drill and tap them, then I put it all back together, rubber band it and clamp it.
I've got a meeting, my mother-in-law just passed away, so can y'all take care of it? So, the board meeting will be Monday night, my house, 5828 88th Street at 7 o'clock. Thank you for your attention.
How about we take just a minute, a moment for silence? Okay. So I have my block centered and held in place with the live center. I have these 4 blocks that form the chuck drilled and tapped. So I put everything back together and hold it with rubber bands and gently with clamps. Push that up against this 2x6 and then just put a small bead of super glue to tack it in place. Take this off the chuck, and I mark just well enough so I can put 2 screws down through the center of these blocks. This screw came through the hole. I just back the screw out, grind it off, put it back in, and then run the tap back through here to clean this mess up. So I have 2 screws and a thin layer of super glue, which I expect to break. I expect to break that super glue joint somewhere along the way. So I have my 2 screws in there, and those screws simply let this chuck flex. That's all it does. Okay. So I start with a solid blank, put this in here and work this face, turn it around and work the opposite face. Then I work one of these faces, flip it around and work its opposite. Then I work the fifth face, and now the fun starts. How do I cut this final face loose and never use calipers? Never do a bunch of math. Never do anything really hard. And the answer is I put this in. Oh, I forgot to tell you, once all of this is put together, I drill through here for a screw, and then I body drill this portion, and then countersink it, so I can hold this in place with 4 screws. And I like this chuck design because I'm holding out here at the end of this block where I'm working. So I have an opposing force, I have a holding force that opposes right where I'm working. It's not like I'm grabbing it back here and working the face where these could break. I'm holding it up here, and I like that. Okay. In order to hold that centerpiece, I came up with this. I took a long dowel, threaded it to loosely fit inside these threads so I can screw it in and just touch. Okay. I put all 4 of them in, then I come back and tighten them just a little, like you would a 4-jaw chuck for metalworking. Okay. The outer blocks hold the outer cube, the bolts hold the inner cube, and now I can work this as if it's a solid piece of wood. There are times,
You do all 4 or just 2?
I use all 4.
Okay,
Yeah, I put just 2 in so I can save a little bit of time,
sure.
but I always use all 4. There may be times when
What's that chuck made out of? Is it maple?
2 before. Maple would be better. If you come up and look at this, you can see where I blew the backside out when I was drilling and tapping it. If I was going to make a lot of these, and I will go back and make this entire chuck out of hardwood. I'll probably use maple and make it as accurately as I can, because some of this stuff is kind of fun. And we're selling the house, I'm moving the shop.
So what did you use to thread that with?
You can buy a tap, or you can take a bolt and use an angle grinder and cut a slot. And then I used a Dremel tool with a diamond to sharpen this edge. And that's what I drilled and tapped it with. I took a nut.
That 1-inch bolt your tap?
Yeah, that's the tap. And then to thread the dowels, I used a nut and just cut angled slots so that the angle was a cutting edge. And then just ran this. And I have a kerf that runs all the way through. And I clamp that with my vice grips to close that off to cut these a little smaller. so that I get that loose fit. Okay? You can buy this stuff commercially made, but I can make it faster than I can get on the computer and find it and order it. Let's see.
Yeah, bolt steel is plenty hard for doing wood.
Yeah.
You can't tap and thread steel with the bolt
That's correct.
for very long anyway.
For what I'm doing, that's plenty hard, and that'll probably last my lifetime, unless I drop it one too many times. Say on the cube, inside a cube, my bolts won't fit. So I'll make 4 spacers. Can you see that? So I make these spacers to raise the surface of that cube so that I can get my bolts onto it. For the star, I do not want to hold this by the points. I'm not that good a turner. So I take a cylinder, drill it out so that's a little bigger than the star. Make the cylinder a little longer than the star point. And now I can get my bolt on it. So I'm holding the cube in the middle and I can exert a pretty good force. And now I can turn. I can turn with the skill of a typical turner. I don't have to be super sharp, super accurate, super slow, super perfect. I can turn like a regular person, and this works. After I've made some of these objects, I've learned that these bolts with an appropriate end on it can hold all of this stuff and more. All you have to do is figure out what do you put at the end of this bolt to hold this object at the orientation you want. And if you can figure that out, you can make anything you want. So it's a combination of 2 independent 4-jaw chucks. One of them is symmetrical, a symmetrical 4-jaw chuck like a Woodturners, and another is an independent 4-jaw chuck inside. See? If you want to make one of these, just one of these, just grab your blank with your 4-jaw chuck and accept the fact that you're going to leave marks and make one. And if it turns out that's something you're interested in, then you can fool around making this chuck. I'll warn you, it costs at least $2 worth of wood.
If you're gonna do it on a 4-jaw chuck, how would you hold it?
Okay, if you're going to make one, just to see if it's something you enjoy, I don't have a chuck with me. Okay. If this represents the gaps between the fingers of your, or the jaws of your chuck, I'd put the corners of those gaps, and I would have marks. All right, come on, Bill. I would have these marks all the way around on every surface. But then you get to make one without any effort. Okay. And then if it's something you like, you can make a chuck like this and then make a bunch of cubes the same size. That's one constraint of this. The cube has to be designed for this. But if you want to make just one and you're willing to suffer these marks, I would just stick it in your chuck. And remember that when you're turning out here, the wood here is what's keeping this thing together. So you have to be gentle. Okay. I've also made another chuck where I just took pieces of wood and taped them on here, mounted this on the lathe, and turned this wood to match the inside diameter of my jaws, and then used carpet tape to hold that in there. And then took this block out, had to chisel it out, and that gave me a 4-jaw chuck with flat jaws. And I could hold it without these marks. I still had the problem of I'm turning out here while I'm holding back here, but that's a standard wood turning problem, right? We do that all the time. One of the problems with that is the frictional force that holds this in is not like crunching down with metal on wood. So you have to be careful that you don't jog that over. You have to be a little more careful. But that's a quick way to make a few of them.
What speed are you turning at?
When I'm drilling, I turn at 500. When I'm boring, using one of my tools, I tend to kick it up to 800.
One more question. So on the four-jaw chuck, like how you have the bolts right now, how would you peg it for that last cut without getting that catch?
There you have to use plugs. That's the only way I know. You have to
Okay.
use the plugs. Now, you might, and the trick to the plugs is to get something to hold it and then have it flush. So another thing, if you'll allow me to speculate, I have not done this, okay? I used wood just as wide as my jaws were deep, and that formed a set of 4 flat surfaces the depth of my jaws. I could extend that out, say twice the depth of my jaws, and those might cover this much. Okay. Then you could have a loose fitting plug that's flush. So now instead of having a press fit, you have a loose fit, but you have to get it flush here. And you can do that with a sander. Okay. And that would hold these in. But if it starts to wiggle, you really, really have a high probability of a catch unless you're a really good turner, better than me. Okay, so you can do just the chuck jaws and accept the damage. You can use that intermediate trick, but you have to be careful. Or you can go to this, and it's actually pretty straightforward.
How large a chuck could you build? I mean, how big a cube could you make?
You know,
Those are 1 7/8, you said, and
I chose an 1 7/8 here because Jim Bob gave me a whole bunch of hard maple that's 2 by
Gotcha.
2, and I cut
Okay.
it, so I had the material, and that defined this chuck. I've made some 3 by 3 with a chuck not this good. I think I could make this 8 inches or so.
okay.
I'm guessing, I haven't done that, but I think I could make this much bigger. Put more screws in here to hold it, but
How big is your lathe?
I have a 12-inch lathe, so I'm willing to put an 8-inch chuck on here.
Right.
Now, what worries me is the longer these get out here, the further out this sticks. There's more forces on it I haven't carefully thought of. These screws are gonna help those forces, be kept under control. But I haven't done any calculations and I haven't done any tests to let me know just how big I can safely go. But I think right now I would go to the shop and build an 8-inch chuck if I had the desire to make one. And I actually do want to make some bigger because the size, it's like a lot of things, the size really does matter on the presentation, the impact of these guys.
If you do make it bigger and you have more space from the edge to the center of your hole, could you then do, say, an octagon? Because if it's bigger, there's more space to put another and have, instead of the 4, 8 going around.
Well, I use 4 because that's the geometry of the piece that I'm holding. And I'm not sure I understand the octagon. So are you thinking of having one of these blocks? Yeah, I think 4 with more screws. As I scale this up, I need to scale how many screws I have holding it. I think that would be a better way. I may also put another screw down this way. Any questions? Okay, I've done a lot of talking, so let me real quickly go through this again. I make a bunch of wood blocks the same size. you might be able to take these straight off your table saw. They don't need to be perfect because you can sand them while they're in here. So you get a set of blocks that are good enough. Yes, sir.
Would you say the name of that book and the author again, please?
Yes, it up there.
Okay.
David Springett, Wood Turning Wizardry.
Thank you.
Does that book have that chuck in it, or is that your design?
Oh, David does a different thing. He turns a cylinder, and then he gets on a bandsaw and he cuts a curve in, and then he cuts a square, and then puts a screw with that. He has a single kerf. So if you imagine this chuck with a square body, a cylindrical outer body, and a kerf running through here, he puts a screw in there to close it up. I didn't think I could bandsaw it that well, especially since my bandsaw blade is broke. And I got carried away with precision and accuracy and stuff like that, like I always do, until I realized that you don't have to be that accurate to make these things look good. You have to be reasonable but not perfect. When I first started turning a long time ago, I got this book from Dover, and it's published back in the 1800s. Hope Zapfel did some incredible work with ornamental turning, and he talks about a lidded box in a sphere, and a cube inside a sphere, and all the platonic solids inside a sphere. Did y'all see that? So these objects have been known for at least a couple hundred years. He references, both authors reference Bergeron, a manual for turners in French, back in the 1800s, early 1800s, where they do the same thing. That's why I got to thinking about some kid sitting in the back of a shop doing this while some guy is talking, because nothing has changed over the last several hundred years, has it? Okay, that's the wood. Screwdrivers and spade bits are cheap sources of good steel to make these tools. An angle grinder with a cutoff wheel will get most of the work done, and you touch it up with a bench grinder, and then when you're done with that, I hone it by hand to preserve the shape and size. Okay. I'll start turning wood now. I'll shut up and turn now if you'll let me. Do you have any questions?
Got too many questions to ask.
Yeah.
We gotta see it,
I don't know where to start.
Too stupid to know what to ask.
Got an hour? Okay. So, what I've done is prepare a set of blanks where I've made all the cuts except for the last one. And in a way you're getting cheated because the first cut starts on the end grain. I work the end grain first, and then I work the side grains. And you earn your money when you make the last cut.
How do you determine how big a bit you're gonna use for your Forstner bit for your initial drilling?
I have a one-page description of how I do this, and it's on my phone. Does anybody want that?
Yeah.
Share it to us.
Does anybody know how to send files?
Yeah.
Who's the youngest person in here?
Maybe you share a file like you share a picture. Pretty much the same.
How do I open this?
Go back to flip phones.
That's the file.
Yeah.
Okay.
So if you can get that started,
Yep.
I'll quickly,
Brick.
this is something that's missing from all the YouTube videos. They experimentally determine all these numbers, and the geometry is so simple. I start with the size of the cube. And now, if I drill from here to here, let's say I'm taking a Forstner bit and I bring it in. If I drill from here to here, on all 6 faces, I'll form a cube of that size. So that cube will be floating inside the outer cube. Then if I undercut far enough to cut past this edge, I'll free that cube.
Cutting them corners out.
If I look inside this cube, there. Where these two undercuts meet,
It's muted.
I get that crisp corner, but if you follow this circle all the way around, the diagonal on that cube has to be smaller than that circle because that's how deep I can undercut. Okay, so I undercut on this side until I meet the wall thickness on this side. That defines how big that, and if you draw a picture, you know exactly how big that is, how big that circle is. That tells me how big this diagonal can be. Okay. Now, this window has to be, I want it bigger than this distance, the width of the cube. That opens it up as enough so I can see inside. But I have to have it smaller than the diagonal of that cube. Anything between those limits, I'm free. I'm free to choose. So I choose a size that matches the Forstner bit that I have. Okay. In my case, I didn't have a Forstner bit that size, so I'm going to drill part of it and then I'll turn the rest of it. But that forms a cube inside of a cube, which is, and then I did the same thing on this inner cube just to make it lighter in area. Okay. So those are all the concepts. And that document, the first page talks about every step along the way. Where I choose this size, I choose the size of the outer cube, the wall thickness, that determines everything else that I do.
Now theoretically, you could take this concept and apply it to a octahedron or something.
If you can make that, okay, are you talking about an octahedron inside a cube or an octahedron as the outer element?
Outer element.
Okay, start by turning a sphere. Then mark that sphere so that you can make an octahedron or dodecahedron or whatever you want.
Right.
And then you make whatever surface you want. Then you find a way to hold that octahedron and bore whatever you, then make whatever you want inside, just like we're about to do here, but you have a different outside chuck.
Right.
So I've chosen an 1.25" window.
Quick to the other camera.
Yeah, I think this camera zoomed in really close is going to be the best bet from here on out.
He's got it, he's got it.
What are you zooming it in better?
Yeah, zoom it in so you can see.
You have to do that on the camera.
Does that help?
Careful with the touch.
Perfect.
start, I found the center and I marked an 1.25 inch diameter hole, and that forms the window. I don't have an 1.25 inch Forstner bit. If I did, that would be the way to go. So, I've got my blank in the chuck with the last surface to be worked facing out. I've tightened all 4 of these screws. These Forstner bits require quite a bit of effort to turn sometimes, so I made a cheater, a post that goes inside the quill, a handle, and this is nothing but a lever. But it allows me to take and go at a controlled pace without a whole lot of excitement. And I don't know if you can see the white paint. That paint is 3/4 of an inch away from the tip of that, away from the cutting edge of that Forstner bit. So that tells me how deep to go on that one. On this one, this is a 5/8 Forstner bit, and that's the size of the hole that I want in the middle. I'm running at about 450. I normally run at 500 RPM for these bits. And as long as I see chips coming out, you guys are not paying attention. I forgot to put these in. There's nothing holding that thing in place. Oops. There's no IQ test. Yeah.
Did anyone else want a document?
Yes.
There's no IQ test to be a demonstrator, is there?
Will do.
Thank you. But it is.
I forgot this during one of my practice runs. I guarantee you, you'll learn what catch means. So I just bring these up and just touch the surface, and then I tighten these. And now I can safely do all this. So here I've marked my depth. I'm just going to the center. I've marked that with tape. The other one I marked with paint for higher visibility. I got that idea from David Springett. He uses whiteout, the correction fluid. And I didn't have any correction fluid, but I tried white paint, and the visibility is so much better. Especially if you're down low and you're trying to see inside there, it makes a big difference. Okay. So I had my whole board to the center. Now I need to clean up this outside diameter and get that to 1.25 inches. Got this, and I'm going to use the screwdriver with the flat tip. This is sharpened on the edge and in both sides.
Can you show that up real close to the,
You got a black background.
Rotate.
What's hurt?
Right about there.
Rotate it. There you go. Hold your palm by there.
there? Oh, I see, okay, I think I see what you did.
Wow.
Now I'm turning, I want to,
No longer a screwdriver, it's now.
so now the cutting tool.
Cutting.
When I bore with Forstner bits, I go as slow as my lathe will go. Mine will go 500 RPM. But when I'm turning, I like to go a little faster, especially if I'm turning a lot of air. The cut that I'm making now will eventually intersect the cuts that I made previously. There it is, I start bouncing.
Yeah.
quite often, I'll raise the back of my tool just a little. I'm negative rake scraping. I'm far less likely to get a catch. And that's one thing I want to avoid right now, is getting a catch. Okay. So, I tend to look for one dimension at a time. And now I have that to 1.25 inches diameter. Now I want to get the depth. And I want to go this is what I use, this is the way I do things in the shop. I design it on the computer, then I sketch it on a piece of paper. And I want to go 3/8 of an inch deep. And this black mark is 3/8 of an inch deep. So I'm going to put a high contrast color down below. I'm going to sight down the front of this turning, and I'm going to plunge this in until I get to that depth. And I want the light down on this piece of high contrast paper, because that's what I'm looking at more than anything else. Now that I have the depth, I'm going to just make a sweeping cut across. I'll clean up the inside of that other hole. And now, can you see inside? The only thing holding this on are those little tabs. And these bolts.
This is where you undercut, just undercut that?
Yep. I'll mark an 1/8 inch and then I'll undercut. Hey, I can't see.
Are there times you want to do all sides before undercutting?
Yes. When I make this guy,
Okay.
I can't get in there and safely undercut because I'll hit the back of the tool on here, and that's high probability of a catch. So I make the entire thing, and I'll put a 1 here, correspond to the 1, and I'll put a 2 here, to correspond to this 2. That way I can put this in with the same orientation, it'll run true, and then I can take whatever object I've made and push it back, tighten the bolts down to hold it, and then I have a lot of room to undercut it. Okay. And that's the reason most of these have a 1 and a 2 on them, so I can put them back and work this space or that undercut. Sometimes I just can't get in there at the beginning. Okay, so now I have my 1/8 inch depth, and that's my wall thickness. And this other one, I can't really mark it, so I'm gonna guess. When I first started doing these, I thought, man, you're gonna have to be super accurate and super careful and all this stuff. And after making a few of them, I realized that it doesn't make all that much difference.
That means what's the tool made out of?
I'm sorry, somebody have a question?
Show us the profile of that tool.
So
That's just a ground spade
this
bit.
started off as a 5/8 spade bit, and I have about a little over a 1/16 inch wide tip.
You got a canvas.
Okay. So I'm about a 1/16 of an inch wide with the tip. The end of that, or the black mark is at an 1/8 of an inch deep.
that flat part of that bit keeps that from torquing, doesn't it? So that flat part of that bit keeps that from torquing?
Uh-huh. And I have this sharpened on 3 sides. But, and this is important, I have dulled these corners. That way if I touch, you'll see when I make the star and some other stuff, if I touch this back end on something, I don't get a catch. When I use this, I'll plunge it in and then I can work it back and forth. When I'm doing end grain, a lot of times I'll just make a whole bunch of plunge cuts and then clean it up. When I'm doing the side grain, I tend to work it back and forth. So I think I had the back hole cut. Now, or I had the inside of the inner cube finished. Now I'll start working on this one. And I'll just work it back and forth. I don't want to touch the inner cube and I don't want to touch that line. I'm just hogging the material out. And now I'm close to the depth that I want, and now I'll plunge in, work back, and then I'll come in and face that cube off, and I'll be finished. David Springett in his book says, take a straw,
Yep.
stick it in there and blow, and close your eyes.
Yeah. He should have opened your eyes.
Cindy Rose will use a little tube.
Just take the tube.
Yeah.
Okay.
You can also get an aerosol can of compressed air.
Oh, that'll work too, yeah.
Yeah,
Okay.
like you use on a computer keyboard.
Okay. Now, this is what I'm looking for.
You see if I can.
My pocket knife is sweeping between the corner of the inner cube and that pyramid that's in the corner of the outer shell. And I can do that all the way around, so I know that that's cut free. And one of the things that I've noticed is that the distance between that pyramid and the cone or the inner cube is different on every one of these, which means I'm not accurately centered, and nobody cares. You know, when I pull this thing out, it really doesn't matter. So some of what I've learned about this is that super accuracy isn't necessary. Okay, there it is, a cube inside of a cube.
Wow. Are you demoing that at SWAT this year?
Pardon me?
Are you demoing that at SWAT?
No, sir, I'm not going to SWAT because if my mom's house sells, I'm not gonna have a chance to prepare anything, so I just decided I'm not even going.
Wow.
Okay.
It's a shame.
I took this out, I put it back in. You see it still runs true. This is 80 grit sandpaper, it's very efficient. This is the reason you don't have to be super accurate with your table saw. You can leave saw marks because you do get a chance to
That's
clean
only
this
true
up.
because you numbered that, right? Because you numbered that?
Yes. If I didn't number it, it would wobble.
Yeah.
Okay, now, those of you who like fingernails, where'd you go? Okay, somewhere I have a pair of forceps. Ah. Okay. I don't know if you could see it, but that guy bouncing around in there, if you stick your finger in there, it'll catch your fingernail. So if you like fingernails attached to your finger,
Do
do it
not.
this way. The way I do it, I take that cube on this on the previous faces, the cube is not bouncing around in there. On this last face it is. So here, I just put 2 bolts in and hold it in place, push it back as far as I can, hold it in place, and then I can get in there and sand it. But be really, really careful with these, because if you stick your finger in there, it can grab you, especially if that object is turning. So I use a forceps. And normally, I'll sand it before I ever take it apart. I got in a hurry. But normally, while I just cut it off, I blow all the junk out, sand it while it's still running true. But I use forceps so I don't hurt myself anymore.
So you're securing that inner cone just to keep it out of the way?
Yes, yeah. Because eventually it'll bounce forward and grab your finger. The last thing I have to deal with is a whole lot of handwork. Because if I look inside, some of these pyramids are really clean. And some of them have a lot of fuzz in here. I don't know if you can see it, but there's some fuzz. Randy, you want to toss it or pass this around? So that's what they look like when they come off the lathe. There's some fuzz on the inside and you'll have to doctor that up. Okay, that's a cube inside a cube.
Interesting.
Here's a star. Okay. Now, here I've turned a 1-inch window, turned it 5/8 of an inch deep, left a 1/4 inch cylinder in the middle that I turned to a spike, and then I undercut it. When I turn this last surface, the only thing holding this in is that 1/2 inch by 1/2 inch column that's sticking through there. Put that in there. On this star, I broke that 1/2 inch by 1/2 inch column yesterday. I thought, what is going wrong here? And then it dawned on me, instead of putting the bolts on when you work the 6th surface, put it on when you work the 5th. And that way you have that strength. Okay. This is the part that's fun with this chuck. I have that spike and I don't want to touch it, so I put that adapter in there. And now I can hold whatever I want. And this is where you get to be clever and create whatever object you want, and all you have to do is figure out a way to hold it.
So right now, it's still centered because you got it attached still.
That's right.
in front.
That's right.
Yeah, if you go too far, then you're sunk.
Start
So
over.
right now, this face, this wood is holding that star centered. And as long as I remember to put these in, I'll just touch it. Okay. Now, this is probably frowned upon by safety folks. You whack yourself a couple of times, you'll learn. Okay, here I want a 1-inch window because the 1.25-inch window would allow that star to come out.
Oh,
And I also need a 1/4-inch cylinder on the middle. There's 1 inch, 1/4 inch. Okay. We're ready. Okay, about 800 RPM. Now, when I start cutting, I'm going to fairly quickly hit air, and that's going to cut this loose. So the only thing that's holding it are those bolts and the cylinders and that inner cube. So I'm in a hurry, so I can get this done in time. But if I get in a hurry, that's the most dangerous thing I do in the shop. So I need to remember to make light cuts quickly, but don't hurry the cut. Okay, I'm about centered. I'm going to just swing this tool back and forth between those two lines. And now I want to get in a rhythm so I get a nice clean cut so that I can do it quickly. And I don't care that I'm kind of forming a valley that I'm forming a V shape. I'll just come back, straighten that cut out, straighten this surface out. Okay, now I'll start going back and forth again. Okay, so here you can see what's happening. I have that 1/2 inch by 1/2 inch square in the middle. I'm starting to cut air over here, and I need to take this 5/8 of an inch deep, which is to that mark. That's why I need a bigger screwdriver. Just, I'm at the ragged edge. I have to be really, really careful. So I would, if you're making your tools, make them a little bit thicker. And to be honest, this spade bit, I've been really happy with it. It's been working. Those tools have worked well. So I think I'll get rid of this eventually. But I've had this for over 20 years. I've been using it as a round nose scraper. It used to be longer, but so here we go. I'm going to start cutting air and wood. I'm in a hurry, but I can't. So I take real fast, light cuts and feed it in just a little at a time. I'm approaching my mark that says I've gone in 3/4 of an inch or 3/8 of an inch. Clean that cylinder up. And now I want to check, before I get too deep, I want to look inside and check that cube, and the corners are square. I haven't chipped it. So whatever I'm doing is working, so I'm going to just keep doing it. I check now because I have a 1/4 inch to go. If I have bad chip out, I know to sharpen my tools or change my technique or do something. But this says I'm doing okay. So here we go. said a while ago, the most dangerous thing I do in my shop is hurry. That wasn't a joke. I have paid attention to things that I do that are dangerous. And I've eliminated a lot of those.
Like wearing the face shield?
Yep. The goggles are sitting over there. I knew when I was working this up that I would forget. Okay, let me get some light. I need to clean that face up, just one finished cut. And normally I have those cylinders and I'll check that those cylinders will fit over that cone, or fit over that, so that I know that I've got that dimension right. Okay? So now I'm going to make one single cut and clean up the end of that cube inside there. Got that part done. Now the fun part. And this is why you need good, clear wood, hardwood. I'm going to start converting that cylinder into a cone. And if I make a mistake, it'll snap. Okay. On mesquite, you don't have to make a mistake. There's little micro fractures going through there. I just touched it and it broke.
You think you could do it with a piece of stabilized mesquite?
Probably. I bet if you could get something inside those little micro cracks to stabilize it. Another thing is, this is the approach I got out of Springer's book, but I don't see why you can't turn the cylinder halfway down and turn half the cone. And turn it the rest of the way down and turn the other half of the cone. That way the delicate part of the cone is supported. That might be a better option. I think that is a better option. So now I've got a 1/4 inch cone and I want to turn it so the tip is 1/8 of an inch, which is halfway. And by the time I get to there, I want to have cut halfway down. That tells me I have the right angle. And all of this is guesswork. Okay, I think that's it. Now that I know what I'm doing, I have to make sure I continue taking light cuts. I can't get aggressive. I did it. What's your language? Let's go ahead and finish this off.
So when you're doing that, are you trying to stay on center or a little below center?
At or below. And sometimes I don't have my tool ground just right, and I'll tip my tool so I get a better cut. And a lot of times I listen to the sound. Okay. That's almost how to do that. Do you get the idea? And I'm not entirely sure what I did wrong. It could have been I could have done something wrong while I was talking and not paying attention. I haven't sharpened my tool since I've started. Maybe that's part of it. Maybe there's just a crack.
It's also cross grain, isn't it?
Yes.
So it could have had a...
Yeah. And that's the reason your choice of wood has to be pretty good. Now, I have glued those back on and let them sit overnight and finished it out. Which,
But I think your idea of doing it halfway
yeah,
and doing your part of your cone and then doing it the rest of the way.
I think that would help a lot of them. On this one, it wouldn't have helped because that broke right at the very tip. And sometimes that happens. That's the reason I don't make these out of mesquite. I love the way these look. But I keep breaking the tips. So, good solid wood for this. I need to undercut this. Oh, I need to do two things. I need to get the window size to 1 inch. Take a little off of that. kinda getting cheated because when I come in and undercut this, all the material in the back has been removed. On the first face, I have to remove all that material. So I sit here and I go back and forth a lot. On this one, I just need to come in and make a couple of simple cuts. So it's deceptive doing it this way, but I just don't have time to do all of it. Now, I need to get inside here and make this undercut without touching that cone. So I'm going to go at it in 2 steps. I have the tool that I used for the cube in a cube, and I'll start with it because it's smaller. And then I'll follow that up with this bigger tool that's marked at 1/4 inch because that's how deep I need to undercut it. And fortunately, I don't need to worry about breaking the tip off the cone anymore. But I rotate my tool downward, slip it in and run past, and now I draw it backwards. And now I'm going to come in, get close to that line. Rotate it in place. And I've got a pretty firm grip on this thing. I want to take light cuts. I'm starting my cut with the tool down, and then I'm rotating it to make the cut, which is not typical. It's probably not good form, but that's the only way I know how to do this. Now, I'm going to do the same thing here, rotate it.
Jim, do you have the same problem with those tools? Because when you have like a swan neck tool, you need to make sure that your tool in the curve is back behind the tool rest.
Oh.
So if you, I noticed that your tool rest was somewhat on your grind.
Oh. So
Does it torque your tool around?
it does. I keep the tool rest close out of habit when I'm doing this, and that allows me to run on this flat. Every now and then I start running up onto here, and that causes me some things, the feel changes. And that's bad turning, that I shouldn't be doing. I should either have it all on here and accept the fact that I'm going to have a lot of weird torque, or get it back here. One or the other, but if I get into that intermediate, that's not a good idea. I need to choose one or the other. Did y'all see what was happening there?
It was lifting up, wasn't it?
When I was
Pulling it out.
when I was back cutting, it was pulling this out.
You're not supposed to chase your block around the shop.
That's right. So let's try that again, and now all I want to do is get this tool in there and then just rotate it and move it in and make that last cut. I don't know what's going on with this. I may have undersized this cube. Okay, last try. I either get it right or I admit defeat. This is the one that has me most nervous about this demonstration because it's the one where I'm most likely to do something like that. Okay.
Jim, have you tried a dab of CA on the end of those cones to help
Oh,
stabilize
to
it?
stabilize it? I have not. I've thought about doing some of that kind of stuff, pre-stabilizing it, and that might be a good idea. Because I don't know how to look at a piece of wood and say that that tip is good.
Might work for the mesquite too.
Yeah, that's what I'm thinking is, as soon as I get the cylinder made, start dabbing super glue on the tip of that cylinder, because it is cross grain. You want to pass that around? Don't break it. That's my job.
Don't drop it or break it.
You gotta make it if you break it.
Yeah. Okay.
Put sandpaper in and sand it.
I like to see one like that about the size of ceiling.
Okay, here's the last one, and this is the reason I may continue doing this, and I might build a hardwood chuck, make it a little bigger, a little better, because once I can make this object, I can make anything out of that that I want to. It's just, can I create a way to hold it? So I started with a cubic piece of wood. I turned a 16th inch deep window that's 1.25 inches, and I come in 1/8 of an inch deep right at this edge. That defines my wall thickness. And then I come in with another tool and I cut at a 45-degree angle until this cut and this cut and this cut meet along this diagonal, and that frees this up. So I worked 5 surfaces doing that, and now I'm ready to work the last surface. You're getting cheated because you don't get to watch me cut this end grain. I'm going to bury this tool up to that white line in here. I've got a firm grip on it, and I'm using it like a cutoff tool. I'm going to come in and bore a little, cut a little ways, then I'll move over and cut, widen that curve, and I'll keep cutting and moving over, just like a cutoff tool. But I'm doing it at 45-degree angle with my arm stuck way out here. I'm not comfortable doing that, okay? That's where I'm most likely to get a catch. The second most likely place I get a catch is when I cut the second face. So I cut the end grain, then I cut the other end grain. And when I cut this face, I have air in 2 places. So I have solid wood, then air, solid wood, then air, and that bounces. And that causes a high probability of a catch. Now when I do the last face, it's mainly air. Okay. So you're getting cheated in that respect, but you don't have to stand here and watch me just keep making the same cut 6 times either. So
We enjoy that.
this time I'm going to make sure my chuck is tight.
Just like the one that's doing a piece of five.
Because you have to do this way because
So I need 1.25 inch window. thinking about this demonstration last night, thinking about how can you save a few minutes here and a few minutes there, and it dawned on me, don't forget to put the bolts in. Whatever you do, don't get to talking and answering questions and getting sidetracked.
Needs a kind of reminder, something that would,
I have some of these in the box that I look at them and I remind. That be that. The handles, this handle is a shovel handle with a hole drilled in it. And then I filled that with epoxy, no, super glue. Just let super glue run down in there.
yeah, and that was just a spade bit that you cut down, right?
Yes, sir, just a spade bit. This too is a spade bit.
Oh, okay,
Does that help?
yeah.
So it's a spade bit with white paint telling me the depth that I need to cut to. And I custom ground this for this particular cut. That's why it has this teardrop shape out here. I left as much material as I could and removed everything I needed to get safely in there. Okay.
How did you make that ferrule? That ferrule that you got there that's got the screw in it?
That's a bolt. So I drilled and tapped the wood and put a 5/8, a half inch bolt in there, and then super glued it.
That's just the head of the bolt.
And this is the head of the bolt, so I drilled out with a shank. One thing you might need to know, if you go to Retool and grab a handful of these, they have different size shanks, which is the reason this is in a separate handle. It's too big to fit in here, so if you look at the shanks, you get the one with the same size. So I just drilled a hole that fit the shank and then drilled and tapped to put a set screw in there.
Uh-huh.
And now I can use the same handle for a bunch of these.
I would suggest using a grade 2 bolt, because a grade 5 is going to be much harder. than a grade 8.
And I'm going to replace this tool with something like this and see how it works. Because I really want to put the round nose back on here and use it the way I used to. Okay, now,
Yes, I guess you spend as much more time, I guess, building chucks and tools than you do the finished product.
you know, that's right. When we were talking earlier about holding it in just a chuck, if you're going to make one, just hold it in a 4-jaw chuck. If you're going to make a bunch of them, it's worth the effort to make one of these, because this opens up a ton of possibilities.
Sure.
But I can make one of these now with an angle grinder with a cutoff wheel, my bench grinder. I can make one of these in an hour. And I don't know how long this thing will last, but it'll last through a whole bunch of this stuff. So there's an investment to be made. And I'm not here to convince you that you should do this. I'm here to convince you that you can do this. Because you got $2 worth of wood, you got $2 worth of steel. If you don't have a broken shovel handle, I'll teach you how to make one. So, let's see. Here's my plan. And I cut a 1/16 inch deep hole, 1 1/4 wide. Then on the edges out here, I cut an 1/8 of an inch deep to define my wall thickness. And then I cut at 45 degrees to free this up. This mark is 1/8 of an inch deep, so I'm going to go half that far. Exactly half that far. that depth. Now I need my width. 15. Just a hair too wide, so that means quit. Now, I want to take an 1/8 inch deep cut here.
No, not this time. We might
Okay. It's useless, but I'm going to make this last cut anyway. I've already cut that free. Normally, I would mark an 1/8 inch deep pencil line all the way around, and I'd come in with this tool and stay on the inside of that pencil line to leave my wall thickness. But I've already cut it free, but I'll show you how I do this. How do you judge 45 degrees when you're doing this stuff? I do it this way. And before you start laughing, let me finish the joke. I actually do this at home because it makes me feel better. It doesn't make it more accurate. It doesn't make it any safer. It just makes me happy. So I use that to line up my tool. That's in the way, so we'll get it out of the way. That'll work. So I come in and I start my cut and I eyeball that pencil line that's supposed to be there. Then I move over and widen the cut. Then there's nothing to cut now. And I continue cutting until that white line touches the inside edge where that pencil line was. And if I did everything right, it's cut free, and it is. I can take my pocket knife and run it around and everything's free. I actually do this at home because it makes me feel better about that. Okay. If I only made stars and cubes, I'd have quit this a long time ago. But making this, somehow it makes me feel connected to Woodturners from 100 years ago. Sitting in the back of the room fidget spinning while somebody's up there talking. But given this object,
Hello.
Really?
I broke another thing. Given this object, I can mount it between centers and turn it. I have a serious bad problem with saying it's good enough. I built this to hold that cube, and now I can mount this between centers and turn the inner object in the cube with that cylinder without moving. A lot of times I'll hot melt glue this on there. That's why it's not sitting. I've got junk underneath it, glue and stuff underneath it.
So that's just a table to stabilize that cube, outer cube?
If I'm going to do more of these, and I have to decide what's going to happen to my life, I'll take a piece of plywood and bring it up and cut it so that I have a bolt here and then something to hold it there, and then I can bring my my banjo either side and get it the way I like it, and that way it's held a little bit firmer. When I start, I will hold this by hand. I'll get my cutting tool up here against my body, and I'll start making the cut, and this will bounce around because this is just barely big enough to rotate, and I'll feel it bouncing around, and then when it quits bouncing, then I'll turn it whatever other way I want it and get it cut. And when it quits bouncing, then I know it's safe to put this in here. Then I can turn through this hole, look through here. If I have a plug sticking out here that I grab in a chuck, I can turn here and here. That's how I made the heart. If I put plugs out both sides, I can cut this in half and mount this side and turn a bowl. this side, I turn the lid, and then put them together and then cut the post off, just like you would if you were making a lidded box. Use the same concepts, the same techniques. You just have the limitation of you can't swing your tool all the way around here. So you have to move this, work over here, and move it, work over here, and then push it back and work this surface, and then pull it back this way and work this surface. So it's an added constraint, but if you use standard wood turning techniques, mount, remount, turn it this way, turn the inside and the outside, put it all together and sand it, then it'll work.
Have you done a sphere inside of the cube?
There is one somewhere.
Ah, okay.
It's not very good. Most of these are what I call demonstration quality. I get it done, I know how to do it. There's tool marks and other stuff. As soon as I get really confident and cocky, the joke was to stand here and talk about, see how my tool chattered. I didn't sand it right, craftsmanship was a little bit subpar, and completely ignore this. I had a catch on the third surface. I turned the end grain, then I turned the end grain, then I turned this surface and got a catch and blew this thing apart, and I thought, I'll finish it. But this is what happens if you don't pay attention to some of these. This is also why a good, strong piece of wood is really critical.
I guess the good news about that is it's contained.
Yes.
When you have problems and it blows apart, it's contained.
It's contained in, yeah, you'll have to damage the chuck to have big pieces fly out, small pieces that come out. Oh, another thing, when you're turning and you're boring in there, it's really cool to look through the hole and see your tool cut. It's not wise though. Wear a face shield or goggles, because that's where stuff flies out.
Sure.
And when you bore in with a Forstner bit, there's a plug that comes out at the end. That plug will not come through these holes unless it breaks. But if that plug breaks in half, then both pieces come flying out. So you'll notice during the demonstration, I didn't wear my goggles, and that's wrong. But you also notice I never look through these holes, because that's where stuff comes through. Every now and then I do, just because it's kind of cool to look inside and see the tool, but it's not wise. That's it, unless y'all have questions about anything.
Great job and really ingenious chuck.
This is my first demonstration like this, and I'm kind of lost on what works, what doesn't, what needs to be improved. So if you have feedback about what could be done to make it better, let me know.
Good job.
Thank y'all.
Good job.